Okay, now we're going to talk about rationalizing the denominator, and this is page 152. 152. And I'll show you what we mean by rationalizing the denominator. So for A, we have 1 divided by the square root of 7r. Now, the square root of 7, like we talked about before, is not rational. So in order to do this, whatever is in your denominator, you multiply. So I'm going to multiply by the square root of 7r over the square root of 7r. So here I do square root of 7r over the square root of 7r. So whatever's in your denominator, multiply it, because this is the same, okay, this is the same as 1. It's the same as a 1. So let's see what happens. When we multiply here, remember multiplication is numerator times numerator, denominator times denominator. So here I do the square root of 7r, and then I multiply. Remember, a radical times a radical just leaves you with, it would be like if you had 49 and r squared. So what's going to happen is if I have the square root of 49 r squared, of course the square root of that, it just becomes the square root of 7r over 7r. Okay, so again here we're simplifying that denominator, and then see, notice we don't have a radical in the denominator anymore, so this is simplified all the way. Now some problems are more complex when we get to B, and this is where knowing your factoring is going to come in. And let's look at that one. So for B, we have simplify 1 over 5 plus the square root of 2. Okay. Now, whenever we do this, what we're going to use is remember when we talked about the conjugates? Okay. Now, if you remember from factoring, if you have a x plus b times x minus b, this gives you x squared minus b squared. And what we can do is use this here. So what we're going to do is when we have something like this, we take 1 over 5 plus the radical 2, and we're going to multiply it by 5 minus radical 2 over 5 minus radical 2. And the reason is because of this. What's that's going to do is it's going to give me 25 minus 2. Let's see how that works. Okay, when I multiply the numerators, I get 5 minus radical 2. And then the denominator, okay, it's the same as here. Let's FOIL it, okay, because this should be FOILed. My first is 25. My outside is going to be negative 5 radical 2. My inside is a positive 5 radical 2. And then the last is a minus the square root of 4. So let's see what happens here. Just like when we did our foiling, and we had the special product here, when we do this, notice that we have a minus 5 radical 2 and a plus 5 radical 2. It always works out that way. That's why we use those radical conjugates, was because those are going to cancel. So what happens is we have 5 minus the square root of 2 over 25, and then it's going to be minus, now the square root of 4 becomes 2. So notice here we end up with a whole number. That's the beauty of using that special product, is that we can get rid of that radical. So again, 5 minus the square root of 2, and let's clean up this denominator. 25 minus 2 is 23. So this is my final answer, and my radical is now magically out of the denominator. Even though I have one in the numerator, that's okay. It's still in simplest form. Okay. So again, what we're going to do when we do these is multiply by what's called the radical conjugate. All right, let's do another one of those. Example 5. This is the next page, page 153, example 5. Now, on this page, I have my first part, 7, radical 5, and it says divided by, I think it says, nope, it says plus, okay, 4 square roots of 45. So in this case, we want to add them. Now, you can only add radicals that have the same, kind of like the base, just like you can't add, if you had x squared plus y squared, you can't add those. They need to have the same base. Now, these do not. But there is a way to convert these particular ones to have the same base. Isn't 45 9 times 5? So we're going to simplify this one. This one is already simplified, and see if we can add those together. So 7 square root of 5 plus 4, and this is times the square root of 9 times the square root of 5. We're dividing up that 45 into 9 and 5. So 7 radical 5 plus 4 times 3 times the square root of 5. Now here I can combine the 4 and the 3. 7 square roots of 5 plus 12 radical 5. Okay, I multiplied 4 by 3. Now notice they now have the same radical expression. They have the same square root of 5 and the square root of 5. So I can add the 7, I can add these together, because it's like I have 7 of these and 12 of these. And if I added 7 of something plus 12 of something, I get a total of 19 radical 5. And that does work. If you check it with your calculator and you put this in your calculator and get a decimal approximation, it will equal this decimal approximation. We do that because this answer is more accurate than if you rounded up here and then got to the end. Then you would have some rounding errors. And we want to avoid that as much as possible. All right, the next one is a subtraction problem. And it is for B, we have 2 radical 2 minus the square root of 18. Now again, this is subtraction, but we can simplify this 18. And that is the first thing that we want to do, is see what multiplies to 18 that has a perfect square in it. Because it is 6 times 3, but that's not going to help me. What I want to do, just copy this part down, and then let's focus on this one. The square root of 18 is, isn't that 9 times 2? Okay, so 9 times 2, and 9 is a perfect square. So copy this down again, and then the square root of 9 is 3, and then I still have the square root of 2 because it cannot be simplified. Now notice I have 2 radical 2's, and then I have 3 radical 2's here. And these can be subtracted because they have the same number under the radical. So let's subtract those. 2 minus 3 is going to be a negative radical 2. And again, you can check. If you put this in your calculator, you can get a decimal approximation. And it equals this one. If you don't follow these rules, some of you may be tempted to do some other things and try and subtract when the radical is not the same. The answer will not necessarily be correct. You might get lucky, but most likely you won't. You will have difficulty. So let's try 4 and 5 on your own. And for 4, this is at the bottom of 153. We have 2 divided by the square root of 5y. And then for 5, we have 3 square roots of 11 plus 2 square roots of 44. Try those. See if you can get the right answer. Practice, practice, practice.